Alrighty guys, this is the review on methods, which was not everyone's favorite chapter, and so this is kind of a lengthier lecture, so hopefully you can take some breaks in between, but it has a lot of important information, and I feel like one of the FRQs on the exam is going to be research-based, and so knowing this chapter is really, really important. Okay, so kind of going through the chapter, we talked about when it comes to research, it is a scientific method. So things like fortune tellers or horoscopes is not going to be considered scientific. Again, also even our common sense and our intuition is not free from error, so be very mindful of that as well. And so, okay, so this is kind of be how I am going to review with you guys is I'm just going to have these blanks and then I'm just going to drag them. And so hopefully you guys will be able to know what the words are before I reveal the answer as a way to study. This is how I would have done it if we were in class together. Okay, so the hindsight bias is the what phenomenon? It is the I knew it all along phenomenon. So let's say somebody breaks up and then you're like, oh, I totally knew it all along. But it's like, did you know it all along? Or do we just kind of think that afterwards? Okay, then sometimes we think we know more than we actually know. So if we were to, if I was to ask you guys, how fast do you think that you can unscramble these anagrams? And if you were to say, oh, in 30 seconds, but then it really took you a minute and a half, then it would actually lead to error. So what is it called when we think we know more than we actually know? It is overconfidence. Excellent. Alrighty, so then for the scientific attitude, we need to have curiosity, skepticism, and humility. So you need to be curious when you're doing research. You have to have a passion for wanting to do the research that you're testing. You also want to be critical and question and be skeptical of data, even just in general when you're reading journal articles or things online, especially during this time. Just be really critical and mindful of what you're reading, and then also be humble enough to admit mistakes and not just publish things that you want to confirm your opinion. And so all of those things come with the scientific attitude. Okay, this is, remember him, the amazing Rondi? He was the guy that said that he offered, I think it was $1 million to anybody who, anybody who could prove to him that they could either, predict the future or do fortune telling, and nobody was able to take him upon his offer, which kind of proves that all those people, no offense to them, what they're doing is not necessarily real, and definitely not science. All right, so the scientific method is how we are going to do research methods. Things when it comes to data, they have to be measurable. So I have to be able to observe direct results. It has to be objective, so leaving our own biases out. And then we have to be able to communicate it and then replicate it to somebody else. And if we can't do that, it's not good scientific method. Okay, again, it also needs to be repeatable. See. All right, so what is it called? So these two words are considered a confusing pair. So what word does it mean to mean consistency? So it means that if we are to do it one day and then do it a next time, it's going to be pretty consistent. So keyword there is reliability. So review, 2 ways to test reliability. Okay, what is it called when you take the SATs one Saturday and then the next Saturday you take the SATs, you're probably going to score around the same score. What is that called? Okay, that is called retest reliability. And then another example of reliability is if I was to test you with one of my exams, you should be able to score the same amount on the odds as you would on the evens. So that reliability would be considered split halves. So reliability, you have test, it's so hard to write on this, retest, and then you have split halves. Okay, I think the other example we used for that as well, sorry, my computer, again, I'm having difficulties, is the fact that if you stand on a scale, you want to be within the same range, 1 or 2 pounds. If you went from like 140 to 203 and then to 98, that would not be a reliable scale. So then you have to get rid of that scale. Okay, this word means that it is supposed to measure what it's supposed to measure. On the AP Psych exam, it is supposed to test you on psychology, not chemistry, not language arts. not physics. And so that means if it's testing you on what it's supposed to be testing you, then it would have validity. Okay, so we have two types of validity from our other chapter. Validity, we have content validity, which means that it is testing you on the content that it's supposed to. And then we also have predictive validity, which basically means that can this exam or this measure help us predict future performance? And so we've talked about driving tests. So driving tests in a way has reliability and validity, because if you were to drive one way on a Saturday and then take your driver's test the next Saturday, it's pretty reliable that you're going to drive around the same ability. And then validity, you drive it, your score on that driving test is essentially going to predict how you're going to be a driver in the future. So those of you that only missed 1 or 2 on your driver's test, you're probably a decent driver. Those of you that missed like 13, you're probably a questionable driver. And so a driving test would have reliability and validity. Okay, then this one is an explanation that integrates principles and organizes and predicts behavior or events. So for example, if we think that low self-esteem contributes to depression, that would be considered a theory. So oftentimes you're going to take a theory and then that is going to lead into a what? It's going to lead into a hypothesis, which is a testable prediction. Okay, so we first have a theory about something, and then we want to put it into the lab, and then we'll be able to test it, and then with our hypothesis. Okay, research, again, requires just this whole cycle that you have a theory, you have a hypothesis, and then you do the actual research and the observations, and then you get data. Okay, so that's all intro to methods. All right, so now we have 5 different methods. Okay, we have case studies, we have surveys, we have naturalistic observations, we have correlation, and we have experimental. So those are the main 5 theories they're going to test you on. So this first set is going to be descriptive theories. They're basically theories, they're methods that aren't going to really control the variables. You're just pretty much going to convey what you're observing and what you collect. So the first one, when you're studying someone in an in-depth manner, that is going to be called a case study. So we're going to study this person in depth. We're going to talk to their family members, their friends, even their teachers. We would talk to them. We'd spend a lot of time with them. And so we've talked about a few case studies in our class. One of them was Jeannie. So Jeannie was the little girl who was found in the basement of her home. Her parents had abused her. She was tied to a potty chair. And so the whole point of that case study was they found her when she was around 13, 14, and she didn't have a lot of language. So the whole idea of that case study was whether or not language was developed. Can you still produce language if you have passed a critical period? And the whole, I think, conclusion would be no, not really. Critical period ends around 7 to 9. And so that was just kind of proving to us where language develops. The other case study we had was Phineas Gage. Remember, he was the person that had the rod go through his frontal lobe. And so once he had that happen, his whole behaviors and mannerisms changed. So he used to be able to plan ahead and was kind and had impulse control. But then once he had the rod go into his head, then he became aggressive and wasn't able to plan ahead. So that case study allowed us to understand the effects of the frontal lobe and the functions. Okay, then we have, so you have to obviously know the advantages and disadvantages of each. Sorry, my dogs are being loud. Stop. Sorry. You have to know the advantages and disadvantages of each method. And so the advantage of a case study is the fact that you can see individual differences, and you can also come up with hypotheses such as, a critical period for language development or a hypothesis of what the brain frontal lobe does. A disadvantage, your go-to answer for the FRQ for all of these methods except for experiment, is that you want to say that you cannot have causality. Okay, that is going to be your go-to easy answer, is that no method can have cause and effect except for the experimental method. Another disadvantage of a case study is that you can't generalize it to the overall population. So Jeannie and Phineas Gage, we all don't experience the same things that they have, and so you can't generalize that study to the overall population. Another one could be replication. I can't replicate another Jeannie. We can't replicate another Phineas Gage. Also, observer bias can happen. When it came to Jeannie's case, a lot of the psychologists became really attached to her. And so if they're looking for something specific, they might look for data that's going to confirm their bias. And then that ultimately isn't necessarily going to be as reliable or valid. So all these different advantages and disadvantages to each method. Okay, this one, a self-reported attitude, where I'm going to give you a questionnaire and you're going to answer. That whole method is called a survey. Okay, so the good parts of a survey is that you can reveal a lot of attitudes from a large group of people and very, very quickly, whether it's through SurveyMonkey or through Facebook or, online or a person. So you can collect a lot of data fairly quickly, which is a positive. Oops, backwards. Okay, but limitations, again, you can't always generalize it to everybody. So let's say the question, even us in Southern California, we don't always have the same opinions as someone from New York or Florida or Minnesota. And so generalizing it to the overall public isn't always going to be able to do that. Also, a lot of times we've talked about people can either lie in their answers or they can exaggerate their answers for whatever reason. They can also answer in a certain way depending on who's asking them. They can be influenced by the person that's asking the questions. Okay, also, it's very easy to be biased by what when it comes to the questions. This is called the wording effect. So just looking at this question, given the number of shootings in schools, should we regulate handguns, true or false? So this question automatically has a bias that gives us the sense that there are a lot of shootings in schools. So it even says right here, given the number of shootings. And so if I'm trying to mandate or regulate handguns, this question is leading me to say, yes, like we should regulate handguns, like that must be terrible. And so automatically there is going to be a wording effect. Okay. What is this one? A tendency to overestimate the extent to which others share our beliefs and behaviors. So this is you going to someone and then they have a completely different answer than you, and you thinking, what? How do you not think like me? What is that called? Okay. This one's called the false consensus effect. We have the false idea that everyone around us believes what we believe. Okay. Then we have to be careful about our samples and populations. And so for this one, when it came to surveys, we talked about the presidential election. When they surveyed a bunch of people and they asked them, who do you think is going to win the presidential election? Everyone said it was going to be Alf Landon, even though in the real election, FDR won by a landslide. Most of us probably don't even know who Alf Landon is. And so the question was, how come so many people believed he was going to win, even though FDR won? And so the whole idea was that they surveyed people who had phones, and this is during the Great Depression. Hold on one second, my dogs. Okay. Out. Out, out. Go, go, go. Go, go, go. Out, out. Come on. Out, out. Okay, I apologize. Okay. So the whole idea of this one was the fact that they had surveyed people with phones, and during the Great Depression, people that have phones are normally wealthy, and normally people that were wealthy were Republicans, and the Republican candidate was Alf Landon. So their sample was not the best representation of the overall population. Okay, then when you're talking about samples, you want to find a sample that can generalize, and you want to use these keywords when you're talking about an FRQ. And we want to find samples and populations that can be generalized to the overall public. So we talked about, if I want to do a survey about adolescents in high school and diversity, out of all the high schools in our district, Valencia probably has the most diverse population. So I'm more able to generalize your guys' data to the overall population rather than a different school in our district who's not that diverse. And so that's kind of what you're looking for when it comes to generalization. Okay, so the individuals who are studied, they are part of the population. So this is going to be the sample. And then the complete group of organisms or events is going to be the population. So You know, you guys, third, fourth, fifth, sixth, you guys are just a sample of my overall psychology population. All of you guys are just a sample of Valencia's population. Valencia is just a sample of Placentia Yorba Linda School District's population. PYLUSD is just a sample of Orange County, blah, 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 blah. So sample smaller, and then you have the population. Okay, again, problems of generalization. You want to be careful of gender, age, ethnicity. So again, if we're talking about, you know, do you think that babies should be allowed on airplanes? You know, you being a young person may say, no, they shouldn't be allowed. Whereas a mom or a parent who has kids would say, no, of course they should be. And so you just have to be really careful of who you're sampling. Same thing with, you know, legalizing marijuana. The younger population are going to be probably more likely to say, yes, we should legalize it, whereas the older population might say no. So you just have to be really careful of your sample. Then there's something called the volunteer bias. So some of us in here love answering surveys and questions and you know, like having free time. And so basically it's a source of bias or error in research that reflects the prospect that people who offer to participate in research studies differ systematically from people who don't. And not that that's a bad thing, but sometimes people that are willing to do a lot of the surveys, they are more willing to disclose intimate information. Sometimes they just have more time, and that can, maybe they're not working, and so they can go to the malls and answer all the surveys. So there's a difference with that population as well. Okay. Again, you want to consider age, education, SCS, marital status, number of children, location. For example, right now during this whole COVID-19 issue, I've been seeing a lot of surveys online saying that we should eliminate all student loan debt. And so considering SCS, people that tend to have maybe a little bit more money are going to be more likely to say, well, no, you know, we should pay back all the loans we used for college, even though it's a huge debt. Like, that is our responsibility, you know, to eliminate, to pay for those and pay for them back. Whereas maybe people that have a lower income or are struggling financially would say, well, no, we should totally eliminate all student loan debt. And so that would alleviate a lot of the financial pressures. So again, when you're doing surveys and like petitions, you have to be, again, really mindful of your demographic, your sample, your population. Okay, then if each member of the population has an equal chance of being included, what is that called? Okay, that is called random sampling. And the way you're going to remember that random sampling is for surveys and random assignment is for experiment is that random sampling starts with an S and so does survey. Okay, so random sampling is for surveys, random assignment is for experiments. Okay, we already did this question. Alrighty, moving on to your last descriptive study. So far we've had case study, we've had survey. The third descriptive study is going to be naturalistic observation. Okay, quick review. Who is the lady that came up with naturalistic observation? And what animals did she study? Review. What is her name? Okay, if you said Jane Goodall, you are correct. And she studied chimps or monkeys. It's going to spell out chimps. Okay, so this whole idea is going to be the fact that we are going to go into people's natural habitat and we are just going to watch them and observe them. It's not invasive or intrusive, and you're just going to step back and you're just going to do it. In our class, your guys' assignment was to go sit outside or sit anywhere and observe people for 30 minutes and to come up with a conclusion about people and their habits. So that was our assignment. This one can be really cool. The advantage is the fact that you can see people again in their natural setting, and so you're not manipulating anything. But again, the disadvantage, your go-to answer is that there's no cause and effect. You cannot replicate it, because if we go and watch someone at the mall for 30 minutes, you cannot replicate what you see or what you saw again to be the exact same way. Also, you can't always generalize it to the overall population, again, just because of your sample and who you're observing. Alrighty, so again, descriptive methods, your three kinds are case studies, surveys, and naturalistic observation. Okay, Now we have a couple more words, another confusing pair. So a psychologist studies the same group of people at regular intervals over a long period of time. Okay, over a period of years. I'm going to study you at 5, 10, 15, 20. What is that study called? Okay, it is called a longitudinal study. So we're going to study people from all the way from beginning to ideally the end. Okay, this one oftentimes is confused with, so this one is where I'm going to take a snapshot. Instead of studying you guys over a long period of time, I might just study freshmen, sophomores, juniors, seniors all at once right after spring break. So doing it all at once, but different populations. That is going to be called a cross-sectional study. And so again, longitudinal over a long period of time. Cross-sectional is a snapshot moment right now. Okay, now moving on to correlation method. So correlation method is very similar. Not similar. Often people are going to assume that correlation is causation. But the whole point of that is that correlation is not causation, even though oftentimes it's going to seem like it's a causation, but it's not. So just different words to know. Okay, correlation coefficient is going to be this number. Okay, we are talking about this number and then the plus and negative symbol. Okay, the number here is going to indicate the strength of the relationship. The closer the number is to 1, the stronger the two items are related. Okay, the plus and negative symbol indicates the direction, whether it's going to be a negative or positive direction. Again, negative and positive in our class does not mean good or bad. It usually means an addition or a subtraction of something. And in this case, it's going to be a different meaning in general. It's going to be a different meaning. We'll get to it. Okay, so words that you want to use. So correlation method is not causation. So it's more about how two items are either related to each other or how they can predict one another. Okay, so good things about correlation method, you can always replicate them, so that's a good thing. A limitation, your go-to limitation is that there's no causal effects. Okay, so again, the numbers are gonna vary between 1 and -1. And so the closer it is to 1, regardless of positive or negative, the stronger the relationship. And again, a number over 1 does not exist. So it has to be 1, positive or negative, but nothing over. So not 1.5, not 1.3, not 2.5. And so a lot of times you're going to get a question on the test where it's going to say, okay, here's negative, 85. Okay, there's going to be 1 point, this is really slow. Really hard to do. 1.25. There's going to be, 75. And there's going to be a negative, 1. Okay. So when you're looking at these numbers, which one has the strongest relationship? The answer is going to be -1 because negative or positive 1 is perfect correlation. And so negative 0.85, that's a pretty decent correlation too because it's over half. 1.25 does not exist. And then 0.75 is also pretty decent too. But the number closest to 1 is going to be the strongest relationship. Okay. So then we have positive correlation and negative correlation. Positive correlation basically means same direction. As one item goes up, the other is going to go up. As one variable goes down, the other is also going to go down. So considering hours of studying, ideally the more you study, the higher your GPA. The less you study, the lower your GPA. Okay, so they're going to have the same direction of arrows. So think for yourself, what are some examples of positive correlations? It can be, the more sleep you get, the better you feel. The less sleep you get, the crappier, or if we were to crappier, that'd be wrong. It'd be the less sleep, the less well, I guess you would feel. Okay. A negative correlation is that it's going to go opposite. So as one increases, the other decreases. So the more you watch TV, the lower your GPA. Okay, another example can be the more you exercise, the less body fat you have. So as one goes up, the other goes down. So opposite directions. Okay, so a lot of times it might seem so clear cut, like, well, yeah, of course, if you study, I'm going to have a higher GPA, blah, blah, blah. But that's not always the case because sometimes people study a lot and they don't have a good GPA. Or how do we know the reason you study a lot is because you have a GPA, you have a good GPA? So we can't just say, oh, because you study, your GPA is high. It could be because your GPA is already high, so that way you continue to study a lot. So it can't always be a causal effect. It's just correlated, but not cause and effect. So again, what that's called is that there can be a third factor. Okay, these are all three of these words are going to be the same thing, and you can use either one to score a point. So there can be a third factor, there can be a confounding variable, and then the third one is extraneous. Extraneous. So third factor, confounding, and extraneous, so like extra, all three of those means that there's something else floating that can be contributing to the results. So that's why you cannot have cause and effect. So for example, here it says the length of marriage is correlated with male baldness. Can we say that marriage causes baldness? Well, if you know my husband, he is bald. But he was bald way before we met. So our marriage did not cause him to be bald. So what could contribute to male baldness instead of just saying, oh, it's marriage? It could be stress. It could be genetics. It could be diet. It could be another illness. It can be anything else. So because there's this other third floating factor that can be contributing to baldness, we cannot say that length of marriage causes baldness, but we can say that the two are actually correlated. Okay, so now looking at diagrams, I feel like this year they might give you guys a graph or data. And so if they give you a scatter plot, again, scatter plots are all these little dots. This one, if you see it, it look like that. This is going to be considered perfect positive. This one is perfect negative. This one is no relationship or causation at all, or not causation, correlation. Okay, there's that. Okay, so if you look at this one, if you just look at this scatter plot, it looks kind of like this. Okay, it's supposed to be a straighter line than that. So it is a moderate positive correlation because it's going this direction. So it's about 0.63. Okay, again, we cannot say when it comes to correlations, not causations. Let's say someone would say, well, I think low self-esteem causes depression. Okay, well, can you really say that? Because how do we know it's not because they have depression and that's why they have low self-esteem? Or let's say it's not even low self-esteem and depression. Maybe it's like a distressing event or a loss of a loved one or a genetic component that is contributing to low self-esteem and depression. So again, the key component is correlation is not causation. Okay. What is it called when I think two things are related? For example, some people have said, whenever there's a full moon, bad luck happens, or Friday the 13th, bad things happen, but really, does it always happen that way? We don't know. The one that was in your book, this little kiddo, they're saying that people that can't conceive and have babies, once they adopt a baby, then they're more likely than to have a biological child. So that's not necessarily true, but a lot of people believe that. And so that is called an illusory correlation. So it kind of looks like an illusion that's not really there, but a lot of times we think that it's there. Okay, so the main thing again for correlation method is correlation is not causation, even when it feels like it is. Alrighty, now moving on to experimental method. So experimental method is the only method that can have cause and effect. Okay, it is going to depend on the independent variable and the dependent variable. So the dependent variable is dependent on the independent variable. Okay, treatment in the experiment is basically the condition received by the participant and its effects are being observed. So this is pretty much what they are getting in order for us to study them. So if I'm testing a new drug, if I'm testing a new program, and I'm trying to give this to a new set of people, that set of people, they are receiving the treatment. Okay, so we can manipulate and control the variables, which is why experimental method is the only method that can do cause and effect. Okay, so this one, the independent variable is basically the thing that we get to manipulate as the experimenter. So if I want to test whether or not breastfeeding is going to contribute to higher intelligence in babies, the breastfeeding is going to be the independent variable because I get to control who's doing the breastfeeding, how much breast milk are they receiving, what time they're receiving it, yada, yada, yada. So because I can control that and I can manipulate it, that becomes your independent variable. That's the thing that I'm testing. Okay. The dependent variable, I cannot do anything with it. All I can do is observe its changes. So basically, the dependent variable is the result. So in this experiment, breastfeeding, I want to know, does breastfeeding have an effect on intelligence? All I can do is just observe what happens. I can't control the intelligence. I can't control who gets what score. I can just observe the result. So then the intelligence ends up being your dependent variable. Okay, so again, you manipulate the independent, you observe the dependent. Okay, this one's just kind of like an acronym that helps you at all. So drive mix. So the dependent is the result. It usually is on the y-axis. You manipulate the independent, it's on the x-axis. Okay, this one, huge word. I really, really feel like they're going to test you on this one. They do it a lot. It's one of those words that students kind of trip up on. And so the key word for this definition is going to be replication. So what is it called what is it called in an experiment that allows you to replicate it next week? You take my experiment from today, and then next week you can do the exact same thing. Okay. That whole idea is called operational definition. So I think in our class we talked about, how do I know if Crest or Colgate is the better teeth whitening, toothpaste? So what I would do is, because our version of white, so your version of whiteness versus my version of whiteness is going to be different. So one way to operationally define whiteness is to be able to have one of those strips with like different levels of white where I can just go up to each person and put it against your teeth and go, okay, that's white. That's like kind of white. That's like off white. That's like, I think you should brush a little bit more. And so that standard strip, that means you guys could use it next week and do the exact same study. And so that white strip is what's going to be your operational definition of whiteness. Another example for intelligence, what is one way that I can operationally define intelligence today versus you guys doing the same experiment next week? That would be with an IQ test. I can give my participants an IQ test. You guys can take that same test, give it to them next week with a whole different group of people. And then that would be our common assessment or our operational definition of intelligence, which then allows for replication for other people to do the experiment. Okay, let's say they wanted to do alcohol and aggression. Does alcohol cause aggression? We can't say that it does because we don't know yet. But if we want to do an experiment, we could. Basically, alcohol would be my independent variable because I get to manipulate it, how much alcohol, what brand, what kind, who am I going to give it to, which group's going to get it. And then aggression is going to be what I can observe and measure, which would be my dependent variable. Okay, so the people taking the alcohol, they're going to be my experimental group. They're the ones that are going to receive the independent variable, whether it's alcohol, a new drug, breastfeeding, whatever the case may be. The other group is going to be my control group. They're not going to take alcohol, but they're going to take something that's like alcohol, which is called what? What is that called? A sugar pill? Okay, it is called the placebo. Good job. Okay, it's pretty much where if we give them this fake pill or this fake alcohol, which makes them think they're drinking alcohol, then we're able to then reduce bias, because if you know exactly what group you're in, then you might act out in a certain way. So us giving you a placebo makes it so it reduces bias. Okay. What is it called if I'm the experimenter and I know what group you're in, but you don't know what group you're in? That is called a blind study. What is it called when I don't know and you don't know what group you're in? That is called a double-blind study. And so the whole point of it is that it's going to reduce bias, because then you as a participant, you're not going to act out in a certain way that you are going to confirm what you think is going to happen. And then since I don't know what group you guys are in, I'm not going to look for things too that's going to confirm my data as well. Okay. Then assigning participants to experimental and control conditions by random assignment. Sorry, I was like, what's that supposed to be? Okay, random assignment. Again, random assignment is for experiments where we just like randomly assign you to whichever group, whether you're the experimental or the control group. Whereas random sampling is going to be for surveys, where I'm going to randomly give people the survey and then they're just going to respond. Okie dokie. So again, double look in your book, know all 5 research methods. Alrighty, now talking about data. We love this part of the chapter, right? Statistics. Okay, so when you're looking at data, you want to make sure you're really careful at looking at the bar graph. So on the AP exam, if they give you any sort of graph or data, be really, really mindful of the numbers and the information, and not just look at the actual drawing of the graph. So like this one, if I'm trying to figure out, oh, you know, which brand of truck is the best, this one is very quickly, I'm like, oh, well, it must be this brand, because look how much higher this bar is compared to the other ones. But when you actually are talking about the actual numbers, and you put it like this, there is a very, very, very small difference in each of the brands. So again, when you're given a graph, be really mindful of the numbers and not just what the visual graph looks like. Okay, what is the most frequently occurring score in a distribution? So this is pretty much review from your other math classes. Okay, it's going to be the mode. So this is going to be the most frequently occurring. Okay, this one, what is the average of scores in a distribution? By adding the scores and then dividing by the number of scores that were added together. This is going to be your mean. And then the last one, the middle score in a rank order distribution is going to be the median. Remember, anytime they give you a median, you want to rank these in order. Okay, or, oh, you know, you're right. It's right here. Okay, so if they have a bunch of numbers in random order and they ask you what the median is, make sure you pull out the numbers and you list them in numeric order and then pick the one that's in the middle. Okay, a question that's often asked on the test, out of all 3 of these central tendencies, which one is the most affected by extreme scores? Okay, the answer is going to be the mean. So a really low score and a really high score is going to most affect the mean more than the other 2. Okay, so remember we did all this. We did the M&Ms. We talked about it. Okay, so when it comes to skewed distributions, so a positive skew is going to basically pull the mean towards the higher end of the scores. Okay, so we talked about this. So it's going to look more like this. That's supposed to be a tail. Okay, this guy right here is going to be Bill Gates. He makes a ton of money. Okay, because he makes so much money, he lives in the U.S., and someone's going to say, well, what's the average income of someone that lives in the U.S.? Well, if we have Bill Gates, who's all the way up here, he's going to drag my low income to the higher end because his score is so extreme that he's going to have a positive skew on my actual income. Okay. When it comes to a negative skew, okay, a negative skew is going to pull it towards the lower end. So it's going to do this. Okay. So let's say in your guys' class, I think there was at least one person in every period that had dropped in the beginning of the school year, I think. So let's say that kid is still here and he's still, or she or him, whatever, he is still my grade book. But for this whole semester, they're at a 0. Okay, so if someone was to ask me, well, which period has the highest average? This kid is going to pull all of your guys' average to the lower end because his 0 extreme scores makes your average way lower than it actually is. So then it's going to have a negative skew on your guys' average. So positive skew, it's going to pull it to the higher end. Negative skew is going to pull it to the negative end. And again, the mean is the most susceptible to extreme scores? Okay, this one's easy. The difference between the highest and the lowest score, you basically subtract the highest from the lowest from the highest, and that is going to be your range. All right, then we have our wonderful bell curve that you need to love and know and please memorize. Okay, so here's again your bell curve. You have to know the different numbers. It's 34, 14, 2. This whole thing makes up 100. Also remember down here is going to be your average IQ scores. So 100 is mean IQ, and then it goes in increments of 15. And then you have your standard deviations. You have 1, you have 2, you have 3 here, you have -1 here, -2 here, and so on. Okay, so according to our intelligence chapter, we said 170 and 130 was high IQ and low IQ. So if someone was to ask you how many standard deviations away from the mean is the person's intelligence, someone that has a 70 IQ is 2 standard deviations away from the mean. When we watched that intelligence video, like what was it? Battle of the Brains. Remember the guy that was in charge of the IQ testing? His IQ, I think, is like 142. So that would make him 2 standard deviations, like 2.5 standard deviations above the mean. So that's kind of just showing you how smart he is compared to the rest of us that are average IQ. I could think a lot of you are higher than average IQ, but like you guys know what I mean. Okay, so then knowing how to use the bell curve. Okay, in a normal distribution, approximately what percent of the scores occur within 1 standard deviation above and below the mean? Okay, 1 standard deviation above and below the mean. Okay, the answer is going to be 68. Okay, here, kind of the same question, just using different numbers. The mean is 550. Okay, you want to put it here in the middle. And the standard deviation is 50. You want to add this number to the mean. So it goes 550, 6, 650, 7. Backwards is 500, 450, and so on. What percentage of the SAT scores fall between 500 and 600? So you're going to do 34 plus 34. So again, the answer is 68. Okay, for this one, for a language test with normally distributed scores, the mean is 70. So we're going to put that in the middle. Standard deviation, ooh, my bad, is 10. So you're going to add this to this forward and backwards. So it's going to be 70, 80, 90, and then 70, 60, 50. So approximately what percentage of test scores scored 60 and above? Okay, so you're looking at the bell curve. So it was 70 was here, 60 was here. So it's going to be 60 and above. So it's going to be 34, 34, 14, 2, and so on. So the answer is going to be 84. Okay. If you need help with this, please let me know. Email me. We will figure it out together. Sorry, my dog is grunting. Okay, variance is SD squared. So what is the variance of a set square of 100? Square root of 100 is 10. Okay, so again, a statistical statement of how frequently an obtained result occurred by experimental manipulation or by chance. So you want to make inferences from your data. And so when are these inferences reliable? So again, review. 1, you need to have your data be representative of the sample. And so again, surveying a school that's not diverse is not going to be a representative sample of diversity in high schools. Even us being in Orange County, we're not the best sample for the overall US because Orange County is very different from Ohio, from New York. Even Orange County and LA County are super different. And so you have to make sure that whoever you're sampling represents the overall population. Okay, the less variable observations are more reliable than more variable ones. This is talking more about reliability. You want consistency. So if I'm going to choose somebody to be on my team, if I'm watching your games and you keep scoring a variable number of points, so like let's say it's basketball, and one day I watch you and you score only 2 points, and the next time you score 36, and then you score 11. It's kind of like that range. It doesn't make you really consistent or reliable. And so I would rather have someone that's scoring like 22, 24, 20, 22, 24, 20, because then I know, okay, well, their average score is around 20 points. I can rely on that, and it's consistent. Also, obviously, more cases is better than fewer cases. I don't want to just watch this player one time and determine whether or not this person is going to be on my team. I want to watch them as many times as I can, because the more times I watch them, the more reliable the data is going to be. All right, guys, last important word. I also think they're going to test you guys on this, especially if it's a methods FRQ. So statistical significance is super important. This is a good thing. We like statistical significance because it is significant. The number that you want to attach to this term is 5%. So basically meaning that statistical significance is allowing data to be 5% due to chance. So someone having a bad day, or it's the weather or something. But basically it means that 95% of the data is because of your independent variable. So statistical significance is great because it means that 95% of it is valid and reliable, and that 5% of it is like due to chance. And so just please, please, please make sure you guys know this one. If you see it on the test, describe it as the fact that it's how much it means due to chance, and that it is a good thing, and that we want our data to have statistical significance. Alrighty, guys, thank you for sitting through that torture again. I know we did not lecture a lot. It is a lot of information, but this is definitely probably one of the most important lectures I feel like they're going to test on, especially for the FRQ. So please email me, contact me if you need me to slow it down, or if you need just an extra lesson on it. We will figure it out together. But hope you guys are having a great day, and I will see you guys soon.